Climate change, past, present, and future of our planet. What's happening to our planet's climate? Let's unravel the mysteries of the past, understand the present, and glimpse into the future to see how our world is changing. Take a look outside. What do you see? Sun or clouds? Warmth or cold? That's the weather. Weather is the atmosphere's immediate state, changing constantly, even several times a day. It's like our planet's fickle mood. But if weather is a mood, then climate is character. Climate isn't about right now, but the average weather conditions over a long period, usually 30 years or more. Climate describes general patterns, average seasonal temperatures, rainfall, typical storm frequency, and wind patterns. For example, saying the tropics are hot and humid while the Arctic is cold is about climate. Understanding this difference is key. A sudden cold snap is one thing, but changing average temperatures over decades is another. So, what shapes our planet's character? Earth's climate system is a complex mechanism with many interacting factors. The sun is the primary driver. Solar radiation is the main energy source that heats our planet. However, Earth's orbit around the sun isn't perfectly smooth, and its axis is tilted. These astronomical factors affect how much solar energy Earth receives at different times and latitudes, causing natural climate fluctuations over millennia. The atmosphere, a thin layer of gas, acts like a giant blanket. It contains greenhouse gases, water vapor, carbon dioxide, and methane. They let sunlight in, but trap some of the heat Earth radiates back into space. Without them, our planet would be a frozen snowball, averaging around -18 degrees Celsius. This natural greenhouse effect makes Earth habitable. Oceans are another major climate regulator. Covering over 70% of Earth's surface, they absorb huge amounts of heat and carbon dioxide. Ocean currents act like giant conveyor belts, distributing heat worldwide. For example, the warm Gulf Stream makes Western Europe's climate much milder. Landscapes also matter. Mountains can block air masses, influencing regional rainfall. Vegetation plays a key role in water and carbon cycles, impacting local and global climate. Even volcanoes, by releasing ash and gases, can temporarily cool the planet by reflecting sunlight. All these factors interact to create a unique and ever-changing climate picture. For millions of years, Earth's climate has naturally fluctuated, going through ice ages and warming periods. But in recent centuries, a powerful new player has entered this complex system, which we'll discuss next. Ready to journey millions of years back to see how Earth's climate changed naturally, long before humans? Our planet has its own ancient record, found in ice layers, tree rings, and ocean sediments. These allow us to look back millions of years to understand how Earth's climate changed long before humans. This is paleoclimatology, the science of gathering clues from surprising sources. One key tool is ice cores. In Antarctica and Greenland, scientists drill into the ice, sometimes kilometers deep. Each layer is like an annual ring, but for the whole planet. These layers trap ancient air bubbles and dust. By analyzing oxygen isotopes in the ice, we can determine past temperatures. The air bubbles let us measure greenhouse gas concentrations, like carbon dioxide and methane, from hundreds of thousands of years ago. It's direct evidence of past climates. These ice archives show a history of regular, grand climate cycles. Our planet experienced epochs where huge areas were covered by glaciers, ice ages. Then came interglacial periods, warmer phases like the one we're in now. These cycles repeated roughly every 100,000 years. The main drivers of these natural changes are Milankovitch cycles. These are astronomical factors affecting the amount of solar radiation reaching Earth. 1. Orbital eccentricity. Earth's orbit changes from more elliptical to more circular with a cycle of about 100,000 years, affecting the total solar radiation intensity. 2. Axial tilt obliquity. The planet's axis wobbles from 22.1 to 24. 5 degrees with a cycle of roughly 41,000 years. A greater tilt amplifies seasonal differences at high latitudes, critical for glacier formation. 3. Axial precession. Earth's axis slowly wobbles like a spinning top, completing a full rotation in 23,000 years. This changes the time of year when Earth is closest to the Sun, impacting seasonal heating. These 3 cycles overlap, altering the distribution of solar energy on Earth's surface. When summer sun in the northern hemisphere weakens due to these factors, snow and ice accumulate, triggering ice sheet growth and an ice age. Of course, other natural factors exist. Major volcanic eruptions release ash and sulfurous gases, reflecting sunlight and causing temporary cooling. Changes in solar activity, though smaller, can also influence climate. Even continental drift over millions of years changes ocean currents and land distribution, fundamentally affecting global climate. It's crucial to understand. These natural processes unfold over vast timescales, tens and hundreds of thousands of years. Changes occur gradually, allowing ecosystems and species to adapt. But what happened when a new, very fast beat interrupted this slow, steady planetary song? We'll discuss that next. This will change your view of how quickly humanity reshaped the planet's climate system, starting with simple steam and ending with global carbon emissions. We've just explored Earth's deep past, where climate changed slowly and majestically, following cosmic rhythms. But about 250 years ago, a new, unexpected instrument entered this multi-million-year symphony: humanity. That's when the Industrial Revolution began, marking an era of unprecedented human impact on the planet's climate system. It all started with a simple but ingenious invention: the steam engine. It needed fuel, and that fuel was coal, a fossil fuel storing energy from ancient forests accumulated over millions of years. Factories, trains, ships, all powered by burning coal, then oil and natural gas. With each new factory, each new engine, billions of tons of carbon dioxide were released into the atmosphere, the greenhouse gas that acts like a blanket for the planet. At first, it seemed harmless. Smoke from chimneys symbolized progress, not threat. But the scale grew exponentially. Earth's population increased, cities expanded, and the demand for energy and resources skyrocketed. We began cutting down forests, giant natural carbon dioxide sinks, to clear land for agriculture and construction, and to use wood as fuel. This was a double whammy: fewer trees to absorb CO2, and more CO2 from burning or decomposing them. By the mid-20th century, with the dawn of the scientific and technological revolution, the problem became even more acute. New industries emerged and agriculture intensified. Methane, another potent greenhouse gas, was actively released from rice paddies, landfills, and livestock, like cattle. The use of nitrogen fertilizers led to increased nitrous oxide emissions. Then came entirely new, artificial greenhouse gases, fluorinated compounds used in refrigerators and air conditioners, which, though smaller in quantity, have incredibly strong greenhouse effects. So if the natural greenhouse effect is Earth's vital blanket, humanity began actively thickening it, adding new layers of greenhouse gases. The carbon dioxide concentration in the atmosphere, which fluctuated between 180 to 280 parts per million, ppm, for hundreds of thousands of years, now exceeds 420 ppm and continues to rise. This change is happening at an unprecedented rate, tens or even hundreds of times faster than the sharpest natural climate fluctuations we've seen in ice cores. This speed is the key difference. Nature can't adapt to such rapid changes. We're already feeling the consequences of this accelerated blanket thickening. In the next section, we'll discuss what symptoms our planet shows today and what it all means for us. Remember the heat wave that hit Europe last summer? Or the unprecedented wildfires in Australia? These aren't just bad weather. They're vivid, sometimes frightening symptoms of how quickly our planet is changing right now. After understanding how humanity thickened the atmospheric blanket, it's time to look at the real consequences. The planet isn't silent. It's sending us signals that are getting louder. These climate change symptoms are already felt worldwide. This isn't just bad weather, but systemic changes affecting every corner of Earth. We're seeing something much deeper than just fluctuations. The most obvious symptom is rising global average temperatures. Recent decades have been the hottest in recorded history. This isn't a few degrees on a particular day, but a stable, long-term trend we can track over decades. Anomalous heat waves are becoming more frequent and intense, threatening people's health, especially the elderly. They cause droughts, ruin crops, and increase the risk of wildfires. Scorching summers last longer, and winter months, when snow was the norm, are warmer and snow is rare. Polar ice caps, mountain glaciers, and permafrost are all melting at an alarming rate. Arctic sea ice is shrinking, opening new sea routes, but also depriving many species, like polar bears and seals, of their habitat. The Greenland and Antarctic ice sheets lose billions of tons of ice annually. These aren't just disappearing beautiful landscapes. They're giant freshwater reservoirs and crucial climate regulators. Their melting has far-reaching consequences for the entire planet. A direct consequence of melting ice and thermal expansion is rising sea levels. Water expands as it warms, and melting ice adds more water. Sea levels are steadily rising. This threatens coastal cities and low-lying islands, intensifies coastal erosion, makes storm surges more destructive, and leads to salinization of freshwater aquifers. For millions of coastal residents, this isn't an abstract threat, but a reality they face. We see not just changes in averages, but an increase in the frequency and intensity of extreme weather events. Hurricanes and typhoons are becoming more powerful, bringing destructive rains and winds due to extra energy in the warmed oceans. Droughts last longer and cover larger areas, leading to water scarcity and agricultural problems. Floods caused by torrential rains are more frequent and devastating because a warmer atmosphere can hold more moisture. Wildfires turn into unmanageable disasters, destroying vast areas and releasing even more carbon into the atmosphere, creating a vicious cycle. Oceans not only warm, but also absorb a significant portion of the excess carbon dioxide from the atmosphere. This leads to ocean acidification, which is detrimental to many marine organisms, especially corals and shellfish, whose shells and skeletons are made of calcium carbonate. Ocean warming also affects marine currents, fish distribution, and the health of coral reefs, which are home to a quarter of all marine species. As climate zones change, many plant and animal species are unable to adapt or migrate quickly enough. This leads to population declines and the threat of extinction for entire ecosystems. These symptoms aren't isolated problems, but parts of one large, interconnected system that's out of balance. If we don't change course, these symptoms will only intensify. What awaits us in the future, and what can we do? That's in the next section. According to the most pessimistic scientific forecasts, without decisive action, the average global temperature could rise by 3 to 5 degrees Celsius by 2100, and sea levels could rise by a meter. What future do we choose for ourselves and the planet? Our journey through Earth's past and present climate has brought us to a critical point. We've seen how climate was formed, how it changed naturally, and then how rapidly we began reshaping it. The planet's symptoms are clear. But what's next? The future of our planet and society depends on the decisions we make today. We stand at a crossroads, and scientific models offer several possible scenarios. Imagine the first scenario: business as usual. This is the path we're on if nothing changes, or if changes are too slow. According to the Intergovernmental Panel on Climate Change, IPCC, the average global temperature could rise by 3 to 5 degrees Celsius by the end of the 21st century. This is a catastrophe. Sea level rise of a meter or more would flood vast coastal areas, displacing millions. Extreme weather events would become the norm: unbearable droughts, devastating floods, deadly storms. Ecosystems wouldn't adapt, leading to mass species extinction. Water and food shortages would trigger conflicts and migration crises. Our planet would become much less hospitable to life as we know it. The second scenario: moderate action. If we take some steps to reduce emissions, but don't reach ambitious goals, then warming could be around 2 to 3 degrees Celsius. This is still significantly above the safe level, but the consequences would be less dramatic than in the first case. Coastal areas would still suffer, and extreme weather events would be frequent, but humanity might find ways to adapt to some of these changes. However, this means a constant struggle with the consequences, huge economic costs, and the loss of a significant portion of our natural heritage. Finally, the third scenario: ambitious action. This is the path proposed by the Paris Agreement, keeping the global average temperature rise well below 2 degrees Celsius, aiming for 1.5 degrees. Achieving this requires complete decarbonization of the global economy by mid-century. This means a radical transition to renewable energy sources, developing new carbon capture technologies, changing agriculture, urban planning, and our personal habits. This is the most difficult, but also the most hopeful scenario. It would avoid the most catastrophic consequences, preserve biodiversity, and give future generations a chance at a stable and prosperous life. It's important to understand that these scenarios consider tipping points, critical thresholds beyond which changes become irreversible. For example, the complete melting of the Greenland ice sheet, the collapse of the Atlantic meridional overturning circulation, or the transformation of the Amazon rainforest from a carbon sink into a carbon source. If we cross these thresholds, even the most decisive action may be powerless. The future isn't predetermined. It's shaped by our decisions today. The choice between these scenarios is a choice between survival and prosperity. Which path will humanity choose? That's the most important question of our time. Faced with such grand challenges, it's easy to feel powerless. But what if I told you that every choice we make, from a light bulb to legislation, matters? The time for inaction is over. It's time to build a future where the planet thrives. We've come a long way. Exploring Earth's climate history and realizing the scale of our impact. Now it's time to answer the most important question. What can we do? Feeling helpless in the face of a global problem is a natural reaction, but it shouldn't paralyze us. On the contrary, understanding the challenge should inspire action, both globally and in our daily lives. Let's start with global strategies, the large-scale changes that require political will, international cooperation, and technological breakthroughs. The key task here is decarbonizing the economy, i.e., completely abandoning fossil fuels. This means a massive transition to renewable energy sources, solar panels on roofs and in fields, wind turbines, hydroelectric power plants, and geothermal installations. Investments in these technologies are growing, and they're becoming more affordable and effective. Energy efficiency is also critical. We must learn to consume less energy for the same tasks. This includes improving building insulation, more efficient industrial processes, developing public transport, and switching to electric vehicles. Every kilowatt saved is a kilowatt that doesn't need to be produced, thereby reducing emissions. Another area is the development of carbon capture and storage (CCS) technologies. These are methods for capturing CO2 directly from industrial emissions, or even from the atmosphere, and then safely storing it underground. These technologies are still expensive and under active development, but they could become an important tool for reducing existing emissions. Protecting and restoring natural ecosystems is equally important. Forests are the lungs of the planet. They absorb carbon dioxide. Large-scale reforestation programs, combating deforestation, and protecting oceans, which are huge CO2 absorbers, play a huge role in stabilizing the climate. Developing sustainable agriculture, reducing food waste, and rethinking approaches to land use also make significant contributions. Global strategies also include adapting to already inevitable changes. This includes building protective structures against floods and sea level rise, creating drought-resistant crop varieties, developing early warning systems for extreme weather events, and ensuring access to clean water. We must learn to live in a changing climate, minimizing risks to people and the economy. But what can we, ordinary people, do in our daily lives? Our individual contributions, multiplied by billions, become a powerful force. 1. Home energy consumption. Switch to energy-saving light bulbs, use efficient appliances, lower heating in winter, and raise cooling in summer if you have AC, and unplug appliances when not in use. 2. Transport. Favor public transport, cycling, or walking. If you need a car, consider electric vehicles or hybrids. Reduce air travel where possible. 3. Diet. Reduce meat consumption, especially red meat, in favor of plant-based foods. Choose local and seasonal products and reduce food waste. 4. Consumption and waste. The principle of reduce, reuse, recycle. Choose products with minimal packaging, repair things instead of throwing them away, and recycle everything you can. Awareness and participation. Learn about the issue. Share knowledge with friends and family. Support politicians and companies that demonstrate commitment to sustainable development. Participate in environmental actions, vote, and express your civic position. Climate change is the most serious challenge of our time, but it's also an opportunity to build a fairer, healthier, and more sustainable future. Every action, big or small, matters. Our choices today will determine what tomorrow looks like. We hope this deep dive into the history and future of our planet's climate has been not only informative, but also inspiring. If you want to continue exploring the fundamental changes that shape our world and stay up to date on the most important topics, be sure to subscribe to the Epoch Echoes channel and like this video. Your support helps us create content that matters.